In this video, we're going to learn how to find the equation of an ellipse and graph it using the following information. Center at 0, 0, focus at 0, negative 12, and vertex at 0, 15. Let's start by graphing the points that we have. Here we have our x and our y axis. Our center is at 0, 0. We know that one focus is at 0, negative 12. So that would be right about here. And we know that we have a vertex at 0, 15. This ellipse is centered at the origin, and the focus and vertex provided lie along the y-axis. That means that the y-axis will be the major axis of our ellipse. An ellipse centered at 0, 0, with its major axis along y, is of the form x squared over b squared plus y squared over a squared equals 1. Where a is greater than b is greater than 0, and b squared equals a squared minus c squared. We know that the value of c is given by the distance from the center to a foci. So we'll note that c is equal to 12. The distance from the center to one of the vertices is a. So we know that a equals 15 because this vertex is 15 units from the center. Using this information, we can find a value for b. b squared equals a squared, which is 15 squared, minus c squared, which is 12 squared. 15 squared equals 225, minus 12 squared, which is 144. 225 minus 144 equals 81. This gives us the value of c squared, and so we know, this gives us the value for b squared, and so we know that b equals 9. Since our ellipse is centered at 0, 0, we have the form of our equation for the ellipse, and now we can plug in values for b squared and a squared. So our equation becomes x squared divided by b squared, where b squared is 225. Where b squared is 81. Plus y squared divided by a squared, and since a is 15, 15 squared equals 225, all equal to 1. since b equals 9, we know that the distance from the center to an endpoint along our minor axis is 9. So we have 9, 0, and negative 9, 0 for the endpoints of our minor axis. We can connect our coordinates to sketch out the graph of the ellipse. And so this concludes our example, as we have identified both the equation of our ellipse and found the graph which represents it. I hope you found this example helpful, and we'll see you next time. Hang on, sweetheart.